This presentation is about cracking hashes. This is for CGS 5131, University of Central Florida. My name, as always, is Rick Lineker. You can't really crack passwords. You can only crack hashes. So to say that we actually crack passwords is actually not correct, or not completely correct. What we do is we have to collect the hashes from the SAM first. Then we look through or generate hashes and compare them to the collected hashes. For instance, let's say you collected the hash 0CB694, etc. Next, you go through a list of passwords, maybe common words or something, hash them as you go through them one at a time, and compare that hash to the hash that you collected. Okay, so if you have a list of 10, you'll go through each of the 10 items in the list, hash it, and see, oh, does this hash, so you go through the list of 10, you hash them one at a time, you take the hash that you generated from the list and you compare it to the hash that you created, and you compare it to the hash that you collected, and ask yourself, does it match? If it matches, you found the password. All you got to do now is look up the password in the list, and that's the one. If you find a match, you have found your password. If it doesn't match, that's not your password. So here's an example with a list of 4 passwords. Let's say you have a list of common passwords such as the following: dog, cat, test, and mouse. And let's now say that you collected the hash 0CB6948, etc. That big long hash that you see in front of you. So we're going to go through the list. Now we're going to traverse the list. Item 1 is dog. So we hash dog. We get F923482, etc. That big long hash there. This does not match the collected hash that we have. The collected hash obviously is 0CB69488, etc. So it's not a match, which means the password is not dog. So we continue to traverse the list. Item 2 is cat. And we hash the word cat and we get 1E0E867, etc. We try to match that to 0CB69488, etc. And we see that it is not a match. So that means that the password is not cat. We continue to traverse the list. Item 3 is test. It has the hash of 0CB69488, etc. And that does match the hash of 0CB69488, etc. Therefore, we have a match. We know that we can use the password test. The password is test. We could, if we wanted to, continue to traverse the list. Although we don't have to, we already have the list. Mouse has a hash of DF4E8FE2, etc. That hash obviously does not match 0CB69488, etc. So this password is not mouse. So the conclusion is that by going through a list of common passwords, you can hash them one at a time and try to match the password you collected. The collected hash was 0CB69488, etc. And this matched the hash for test. This means that the password is test. Please note though, in rare cases, different strings can create a hash of the same value as another string. So these are actually called hash collisions. And if 2 different strings create the same hash, it's called a collision. And this happens every so often in computer science things such as hash tables. But let's say your password really isn't test and it's something else. Well, test is still going to work and let you log in, because test will still create the same hash that whatever it is, maybe what was correctly the password created. So it really won't matter as long as the hashes that are created are the same. So what we've demonstrated is really known as a dictionary attack. A dictionary attack is performed when a list of common passwords and or words are hashed and matched with a collected hash. And when I say common words, that would be you just get a dictionary of 20,000 words and you can use that to perform a dictionary hash. The most common program for doing dictionary attacks is called John the Ripper. Now this is why when you have a really complex password, you're not allowed to just use common words, because common words are so vulnerable to dictionary attacks. So here I am at a website that has John the Ripper available for download. And of course I could buy the t-shirt if I wanted to, which would be really cool for the next hackathon. But I'm going to go ahead and download the Windows binaries. Obviously source code is available. I mean, almost all of this stuff is going to be open source. There are a few exceptions. But, okay, so John the Ripper. And I'm going to go ahead and put that. Okay, I'm going to go ahead and put that actually in my, I'm going to make it easy on myself. And by the way, you might see that Windows says that this is potentially harmful software, and it's almost always going to do that. So as it turns out, when I snipped part of this video out, I had to go ahead and turn a Windows Defender off, or at least the real-time protection. I couldn't get it to work. Otherwise, Windows Defender kept killing John the Ripper. Okay, so there we go. Okay, so before we go too far, let me just show you. I actually created a PW dump file based on just a bunch of passwords I made up. And these are actually the username. However, a lot of times it'll create, when you go online and use those online tools, it'll put the password there. But these are actual just names I made up. So this is called hash.txt, and I created it specifically for this example. Okay, so I have John the Ripper here, so you just run John, and it'll show you all the command line parameters. And this program really has quite a few options. You know, I'm only going to show you a pretty high-level view of it, but you can do quite a bit. So I say John show hash.txt. Okay, so that was almost instantaneous that it found the password for each one of these names. Actually, so it doesn't look like it found a password for Rick, but notice all the others are name, colon, password, colon. Well, Rick is Rick, colon, colon. What that means is that the Rick username has a blank password. So that was less than a second to go through the entire list and find a match. So let's go ahead and do something a little more difficult. Let's go ahead and add to it James 1007. We'll create a hash for life is cool. Okay, go to the hashes, grab this. Now let's see if John the Ripper can actually earn its salt. Now let's see what John the Ripper is made of. It actually did not find life is cool, exclamation. So this is a perfect example of why those simple word-based passwords are not going to work. So now we're going to branch out to a program that has a graphical user interface. We'll go to HashSuite, and this is what it looks like. Go ahead and download it here. And we're going to download the free version. Although if you're going to use this a lot, I would definitely recommend the paid version. Okay. All right. So I'm going to go ahead and do the same thing and use bad practice and go ahead and just copy this in to make life easier for me. And I still have Windows Defender disabled, but I'm not sure it would find this. Okay, so let's run hash suite 64 and see what kind of. Let's go ahead and import. We can actually import the hashes from that file we're using. So we'll say hash.txt. That'll be a little easier. We can actually go directly. Okay, so here we have it imported the hash file. We can go ahead and start this. Okay, it found all of the passwords almost instantaneously. So this actually works well and has a graphical interface, so you might enjoy it a little bit better. Okay, so here it loaded this last one, which was "Life was cool!" exclamation, and it was not able to find that because it didn't have a clue in its dictionary. So one of the interesting things is you can change a lot of your rules so that it's able to sort of mix and match uppercase, lowercase numbers, and so forth. So if I went ahead and added something, say dog for cat, this program could actually find it because it has all of these options. Or it could find dog 1 or dog 1 2 just because of these options here. So there are quite a few options it has available.